Welcome to the Micropropagation of Coffee. I'm Stephen Starnes. I'm affiliated with UH-HILO and CTAHR. The grants were provided by the USDA, NIFA. We are using a multi-step process to generate somatic embryos from field-grown coffee leaf disc. The first step uses fully expanded medium green leaves that have not fully matured and become hard and fibrous. The completely mature dark green leaves will produce less callus or fail completely. Very young tender leaves will just turn brown and die before producing callus. So I'll describe all the steps involved with the embryo production, and I will show you photos as well of each stage. The second step is to move the callus to B4N4 media with high levels of BAP and some NAA and antioxidants for embryo induction. This stage is very slow at 6 to 12 months. BAP is a cytokinin typically used to induce shooting, and NAA is an auxin typically used to produce callus or rooting. And after this stage, little white embryos will develop, and we move those to C2B media. It has lower levels of BAP and NAA, and we get expansion at about 30 to 50% per month. It just depends on the temperature and the cultivar. After this, we move to C2B0 media, which has metatopolin and gibberellin for embryo elongation. The metatopolin is just a different cytokinin. It's less inhibitory to rooting. And it has been reported to produce fewer anomalies in development later on. The final stage after we have elongated embryos is to move it to low metatopolin media. A number of them die at this stage, and as well as at the C2B0 level. A lot of things just fail to develop and will turn brown and just fail completely to go further. After harvesting the leaves, I treat them for 45 minutes in 15% Clorox plus a few drops of Tween 20. That's a very mild non-ionic detergent which acts as a surfactant. At this point, after they're out of the bleach, we're working under a laminar flow hood to maintain sterile conditions. So I punch the disc on sterile paper and place them in a tube of water to remove the Clorox. Next is a treatment with 350 micromolar silver nitrate for an hour and a half. The silver nitrate kills many fungi and bacteria, and we typically have less than 10% contamination from field-grown leaves. It might be nothing with greenhouse grown, but that's very good with field-grown material, especially from Hilo and Kona. After the silver nitrate treatment, place the leaves on semi-solid coffee media, the undersurface up. This allows for better gas exchange. The media is gelled with either Gelrite or agar. This slide shows the callus development at about 31 days after initiation. I'll show you a close-up of it next. In the close-up, you can see lumpy callus forming around the edge of the disc, and in some cases covering the entire disc. After 5 to 6 weeks, the callus is cut up into smaller pieces and moved to embryogenous media. Embryo production takes about 6 to 12 months, and I've tried multiple combinations of growth regulators that are supposed to induce embryogenesis. Nothing has speeded up the process so far, and there's a lot of variation between cultivars and also the number of embryos you get in each tube. The photo below shows a cultivar called Maite, and it produced a lot of embryos in 2 of the tubes. Not all of them look like this. These photos show the early stages of embryo formation. As you can see, it's variable from tube to tube. Some tubes form no embryos, while others form very many. Embryos are moved from the B4N4 media to C2B media for proliferation. At this stage, the secondary embryos form on the mature embryos, and elongating embryos, or even some of the larger ones at the globular stage, are moved to the next stage for further development. I typically do that every 21 to 30 days. This is just a close-up of the C2B media plates. You'll probably notice a lot of browning. I have not figured out a way to get rid of this. It just seems to happen with coffee, and even with higher levels of antioxidants, it doesn't seem to make much difference. Embryos are moved to C2B media with lower levels of plant growth regulators for further development. I tried low levels of BAP, but still had a lot of secondary embryos forming. At this stage, you really want the embryos to mature and develop. I switched the cytokinin to metatopolen and got fewer secondary embryos and better development. This slide shows embryos in C2B0 media. The ones that were rooting at this stage, most of those seem to die and not develop further. This is another cultivar on C2B0 media. The arrow is pointing at a cluster of plantlets that can be broken up and placed on media with very low levels of metatopolen and a little antioxidant, and the leaves will expand, and at that point they can be moved out of tissue culture for rooting. Liquid media was tested to determine if we could increase throughput. One variety seems to develop normally, but others form clumps of embryos that adhere to each other. The one with the normal growth is shown below. This slide shows embryos grown in liquid C2B0 media for about 6 weeks. Many of the embryos were moved to plates for development. As you can see, many of these have already started to elongate, and a few might have some emerging leaflets. In about another 6 or 7 weeks, they'll look like little plantlets, or many of them will. Again, we still lose a lot of them at later stages of development. This slide shows a cultivar that doesn't grow very well in liquid media. It formed tight, adherent clumps of embryos that were rather difficult to separate and didn't really develop normally. So I abandoned this particular cultivar in testing in liquid media. This is the final stage in vitro. It's a low PGR media for leaf expansion and some root development. I used a low level of IBA and stressed and apparently killed several hundred plantlets before I realized that it was a problem. This is another batch of plantlets in low metatopolen media with no IBA. And as you can see, there are quite a few of them that are developing normally. There are a few that don't look very good and may die later on, but a large portion of them will develop. Currently, we have about 30 magenta containers with developing plantlets, and over the next month, I'm hoping to generate at least 30 to 50 more. Most of the developing plantlets died, and it appears that low levels of IBA are fairly toxic to coffee. And IBA is commonly used at the rooting stage for many plants. I've omitted IBA, and I'm now using low levels of metatopolen, which seems to be working. Metatopolen is a cytokinin typically used to induce shoots, and it is reported to be less inhibitory to rooting in some plants. Even still, a number of embryos fail to develop. So in summary, the process to generate embryos is slow. Every cultivar responds differently. And the embryo induction step is the slowest part of the protocol in the B4N4 media, and it takes 6 to 12 months. Embryo proliferation in the C2B media is a bit faster, with about a 30 to 50% increase in embryos each month. Development's a bit uneven, so you have embryos at all stages in every plate. Elongating and larger globular embryos are transferred to C2B0 media, and many stop developing at this stage or in the final stage with low plant growth regulators media. So far, a proprietary strain seems to be performing better in culture than the other varieties.